Have you ever wondered how scientists separate mixtures of compounds to understand their properties? Well, one answer lies in a technique known as high-performance liquid chromatography, or HPLC for short. This technique is a cornerstone in the world of analytical chemistry, and today we're going to dive into its construction and uses. At its core, high-performance liquid chromatography is an advanced form of column chromatography. Unlike traditional column chromatography, which relies on gravity to pull a solvent through a column filled with a stationary phase, HPLC utilizes a high-pressure pump, making the process not only faster but more efficient. The construction of an HPLC system is quite complex, with each component playing a critical role in the process. The system begins with a solvent reservoir, or mobile phase. This mobile phase, often a mixture of water and organic solvents, is responsible for carrying the sample through the system. Next, we have the injector. This is where the sample is introduced into the system. The sample, once injected, is carried into the column by the mobile phase. The real magic happens in the column. The column is packed with small particles, or the stationary phase. Each compound in the sample will interact differently with the stationary phase, causing them to move through the column at different rates. Following the column is the detector. The detector's job is to identify and quantify the compounds as they elute from the column. The data from the detector is then sent to a computer for analysis. High-performance liquid chromatography is used in various fields. In pharmaceuticals, it's used to analyze the purity and content of drugs. In environmental testing, it helps identify pollutants in samples of air and water. In forensics, it can detect drugs or toxins in biological samples. The food industry uses it to quality check products for additives or contaminants. And in the world of research, HPLC is indispensable for studying and understanding the complex chemical compositions of natural and synthetic materials. To summarize, high-performance liquid chromatography is a powerful and versatile tool in the world of analytical chemistry. It's constructed of several key components: the solvent reservoir, the injector, the column, and the detector. Each plays a crucial role in the process, working together to separate, identify, and quantify compounds in a sample. Its uses are wide and varied, spanning industries from pharmaceuticals to food, environmental testing to forensic science. So the next time you take a sip of your coffee, remember that a tool like high-performance liquid chromatography might have been used to ensure its quality and taste. Or when you take your medication, know that it's thanks to techniques like HPLC that you can trust its safety and efficacy. It's an invisible part of our daily lives, yet it plays a significant role in ensuring the world we live in is safer and more understood. This is the fascinating world of high-performance liquid chromatography, an unsung hero in the realm of science.